Okay, I'm back, and now we want to talk about the how fast equation, the how far equation, and then the hybrid equation. So let's begin with the how fast equation, which is going to be this one here. So you're going to use this equation when you need to calculate how fast something is going. And notice that this equation right here is essentially the same as this equation up here. So that if you were to take this equation and then solve it for V final, you get this equation right here. So that as long as you know this equation, you really don't need to worry so much about this equation up here. So any equation or any word problem that can be done with this equation, you can do it with this one. So this one is very, very important. The difference between the two equations is that this is a instantaneous velocity, whereas these things are dealing with averages. So your average velocity and your average acceleration, whereas these are instantaneous. But if you have to solve a word problem, as long as you know these two equations, you're going to be pretty set for the exam. So here's an example of how to use the how fast equation. So again, run through that and see if you can understand it. Now, it's very important to keep your sign conventions so that if it's a velocity that is moving to the right, make sure and use a positive V for that. If it is an object that is going to the left, make sure and use a negative V when you plug that in there. And the same thing for the accelerations. Now the T is going to always be positive, but the A, it can be positive or negative. And so remember that sometimes the velocity might be going this way and the acceleration might be going in the opposite direction. So be very careful when you're doing a word problem using the how fast equation. Okay, then you have the how far equation. Now I also want to mention, don't worry about derivations. So the important thing is to know the how fast equation. And so you can see in that slide there that I show where does it come from. It can also be derived using calculus. So this one is deriving it using algebra. But don't worry about it. So on the exam, the thing is, if I give you the formula, are you able to put the correct numbers and the sign of the numbers into that formula? So this one is the how far because it tells you how far, R, does it go. So here is an example of how you might use the formula. Remember, when you're solving word problems, always try to write down all the letters at the very beginning. So what am I given in the problem? Use the units to help you to figure out what letter does it represent. So if you see, like for example, 7 meters per second squared, and you can't figure out what does that represent, notice it's meters per second squared. That's acceleration. That's the official metric units for acceleration. So you automatically know that that's going to be an A. So use the units to help you to determine what letter to use. And then the next step is, once you got your letters, do you have a formula that has all of those letters in it? And so then you can go back and look at these equations and figure out which one is the best one to use to solve the problem. Okay, then you have the hybrid equation. And so the way that the hybrid equation was generated is if you take this equation right here and you solve it for the letter t, and then take that and substitute it in for this t and then this t, and then do a whole bunch of simplification, you end up with this third equation. And so this is called the hybrid because it's a combination of this equation and this equation. You're not going to use it on the exam, but it is fairly useful. So if you have a word problem and they don't mention time, then that's a pretty good indicator that you ought to be using this equation to solve the problem. But you shouldn't have to do that on the exam. But it's a very, very nice formula. Okay, let's take a break, and when we come back, we're going to talk about up and down motion.